Welcome, my friends! In the past few videos, we have introduced logs and talked about a few key properties of logs, including the change of base formula, the power rule, the product rule, and the quotient rule. In this video, we will apply those properties to solve a variety of problems. Let's try 2 plus 4 times the natural log of x plus 2 is equal to 7. In order to solve for x, we need to isolate the natural log onto one side of the equation. We subtract 2 from both sides to get 4 times the natural log of x plus 2 is equal to 5. Dividing both sides by 4, we have the natural log of x plus 2 is equal to 5 over 4. Now we can rewrite this as an exponential using the idea of left, right, and center. We know we need blank to the blank is equal to blank. Left is the base of the log, which is e, since we have the natural log. Right is the answer of 5/4, which becomes the exponent. Center is the argument of the log, which is x plus 2. We have e to the 5/4 is equal to x plus 2. Subtracting 2 from each side, we have x is equal to e to the 5/4 minus 2, which is our final answer. You could type this into your calculator to get a decimal approximation, but oftentimes you will express your answer like this, as this is an exact answer. The calculator will only give you an approximation once you put it into decimal form. How about log base 8 of x is equal to negative 2? In exponential form, this is 8 to the negative second power is equal to x. As the left value is 8, the right value is negative 2, and the center value is x. Well, 8 to the negative second power is the same thing as 1 over 8 squared, which is 1 over 64. Therefore, x is equal to 1 over 64. How about log base x of 125 is equal to 3? The best way to solve this is to rewrite it as an exponential. The exponential form of this log is x to the third power is equal to 125. Now we can solve this by taking not the square root, but the cube root of both sides. We want to know what number can you multiply by itself 3 times and get 125. Well, hopefully you said 5, as 5 to the third power is equal to 125. So 5 is our answer. Let's try negative 5 plus log base 2 of negative 2x is equal to negative 4. Adding 5 to both sides, we have log base 2 of negative 2x is equal to 1. Now let's rewrite this in exponential form. Blank to the blank equals blank. Using left, right, and center, we have 2 from the left, 1 from the right as the exponent, and negative 2x from the center. 2 to the first is just 2, so we have 2 is equal to negative 2x. Dividing by negative 2, we have x is equal to negative 1. How about 5 to the x plus 9 power is equal to 9? Well, this problem has something we want to solve for in the exponent. And remember that the power rule of logs allows us to move the power of an argument from a log out front. Let's apply the log to both sides to get log of 5 to the x plus 9 power is equal to log of 9. Now we can apply the property of logs that says that we can move exponents out front to simplify this to x plus 9 times log of 5 is equal to log of 9. We can divide both sides by log of 5 to get x plus 9 is equal to log of 9 divided by log of 5. Subtracting 9 from both sides, we get x is equal to log of 9 over log of 5 minus 9, which is an exact form answer. But if we wanted to find a decimal approximation, we could go to the calculator. We type in log of 9 divided by log of 5, and then minus 9, which equals negative 7.63 if we round to 2 decimal places. Let's try e to the negative 5x is equal to 11. Again, we have a variable in the exponent, so we can take the log of both sides to simplify this. But since we have e raised to a power, it will be more convenient to take the natural log of both sides. We have the natural log of e to the negative 5x is equal to the natural log of 11. Using the log of a power property to bring the negative 5x out front, we have negative 5x times the natural log of e is equal to the natural log of 11. Well, you may or may not realize this, but the natural log of e is just equal to 1. It's literally asking e raised to what power equals e. which is just 1. E to the first power is equal to e. So that part disappears from our equation, and we just have negative 5x is equal to the natural log of 11. Dividing both sides by negative 5, we have x is equal to negative natural log of 11 over 5. If we want a decimal approximation, we go to our calculator and type in negative natural log of 11 divided by 5, which is equal to negative 0.48 if we round to 2 decimal places. How about the natural log of 2 plus the natural log of x minus 2 is equal to 3? Since this is the sum of two logs, we can rewrite it as one log using the log of a product property. We have the natural log of 2 times x minus 2 is equal to 3. Simplifying the argument, we have the natural log of 2x minus 4 is equal to 3. Rewriting this in exponential form, we have e to the third power is equal to 2x minus 4. Adding 4 to both sides, we have e to the third power plus 4 is equal to 2x. Dividing each side by 2, we have x is equal to e to the third power plus 4 over 2. If you want to, you could type this into your calculator to get a decimal approximation. We have parentheses e to the third power plus 4, close parentheses, divided by 2, which is approximately 12.04. Let's try this one. We have the natural log of x minus 1 minus the natural log of 2, which is equal to 3. Since we have the difference of logs, we can combine this into one log, which has an argument that is the quotient of the two arguments, using the quotient property of logs. We have the natural log of x minus 1 divided by 2 is equal to 3. Rewriting this in exponential form, we have e to the third power is equal to x minus 1 over 2. Multiplying both sides by 2, we have 2e to the third is equal to x minus 1. Adding 1 to both sides, we have x is equal to 2e to the third plus 1. If we want a decimal approximation, we can type this into our calculator. 2e to the third plus 1 is equal to approximately 41.17. Let's try this problem. We have log base 5 of x minus 6 is equal to negative log base 5 of x minus 2 plus 1. We probably want to get the logs onto the same side of the equation, so we can combine them using one of the properties of logs. Let's add the log from the right side to both sides of the equation. We have log base 5 of x minus 6 plus log base 5 of x minus 2 is equal to 1. Since we have two logs added, we can combine them into one log that has an argument that is the product of the arguments of the two logs. We have log base 5 of x minus 6 times x minus 2 is equal to 1. Let's FOIL out the argument. We get log base 5 of x squared minus 2x minus 6x plus 12 is equal to 1. This simplifies to log base 5 of x squared minus 8x plus 12 is equal to 1. We can use the idea of left, right, and center to rewrite this as 5 to the first power is equal to x squared minus 8x plus 12. Subtracting 5 from each side, we have 0 is equal to x squared minus 8x plus 7. We need to factor this to solve the problem. We need two numbers that multiply to 7 and add to negative 8. The two numbers are negative 7 and negative 1. So we have 0 is equal to x minus 7 times x minus 1. By the zero product property, that means that x can equal either positive 7 or positive 1. Now we are going to want to check our solutions in the original function to make sure that they don't give us an error. Checking 7, we have log base 5 of 7 minus 6 is equal to negative log base 5 of 7 minus 2 plus 1. This simplifies to log base 5 of 1 is equal to negative log base 5 of 5 plus 1. We know that log of any base with an argument of 1 is 0, and a log with the base and argument equal to each other is equal to 1. So we have 0 is equal to negative 1 plus 1, which simplifies to 0 is equal to 0, which verifies that x equals 7 is indeed a solution. If we plug in 1, we immediately see that there is a problem. Let's just look at the right-hand side. We would have negative log base 5 of 1 minus 2 plus 1, which simplifies to negative log base 5 of negative 1 plus 1, But we know that logs are not defined for negative numbers, so -1 cannot be a solution. So our only solution is x equals 7. Let's try this one. We have 64 is equal to 16 to the negative x minus 5 power. We could solve this by taking the log of both sides to get the variable out of the exponent, but there is another way to solve this. If we can match the bases, that will mean that the exponents must be equal to each other. What I mean is, both 64 and 16 are powers of 4, so we could rewrite this as 4 to the third power is equal to 4 squared to the negative x minus 5 power. We can distribute the exponent on the right-hand side by multiplying. We have 4 to the third power is equal to 4 to the negative 2x minus 10 power. Since the bases are the same, the exponents must be the same too. So instead of using logs, we can simply set the exponents equal to each other. We have 3 is equal to negative 2x minus 10. Adding 10 to both sides, we have 13 is equal to negative 2x. Dividing by negative 2, we have x is equal to negative 13 over 2, which is our answer. Okay, one last problem. We have 12 to the negative x minus 8 power is equal to 13 to the negative 4x power. We're going to really struggle if we try to find a common base between 12 and 13. It's not going to happen. We're going to have to take the log of both sides. I'm going to use the natural log. That allows us to pull the exponents down. We have negative x minus 8 times the natural log of 12 is equal to negative 4x times the natural log of 13. Distributing the left side, we have negative x natural log of 12 minus 8 natural log of 12 is equal to negative 4x natural log of 13. Let's get the x term on the same side of the equation by adding x natural log 12 to both sides. We have negative 8 natural log 12 is equal to negative 4x natural log 13 plus x natural log 12. Let's factor out an x from the right-hand side. We have negative 8 natural log 12 is equal to x times negative 4 natural log 13 plus natural log 12. Let's divide the whole right-hand side by what is in parentheses. We get x is equal to negative 8 natural log 12 divided by negative 4 natural log 13 plus natural log 12. We might want to get rid of the negative sign out front by distributing it to the denominator. We have x is equal to 8 natural log 12 divided by 4 natural log 13 minus natural log 12. This is our final answer. If you wanted to, you could plug this into your calculator to get a decimal approximation, but this is the exact answer. Alright my friends, that wraps up our video relating to equations involving logs and exponentials.